Space. Where did it come from? And what's in it? Since the first organisms on Earth looked up to the sky, well, they didn't wonder anything because they didn't have brains or eyes to see the stars above yet. Eventually though, we did develop eyes to see the sky, and a little while later, brains too. Some animals use those stars to navigate, and some more top-heavy animals began to wonder what those points of light are. Bang! It's astronomy time. Actually, first it's myths time, because before we knew what space was, we decided to invent some cool stories. Like this. Doesn't this look like spilled milk to you? No? Well, lots of cultures thought so, with the Greeks having a totally normal story about Zeus, wanting his mortal son to become a god. So obviously he gets his son to drink breast milk from his divine wife Hera while she is sleeping. She woke up and said, "What the heck?" pushed the baby away and spilled milk everywhere, which became the Milky Way. Lads, even if you're a god, don't do this.
Bro, not cool, not cool.
During the thousands of years it took for civilization, agriculture, and societies to emerge, early people were already looking to the sky and building circles on the ground that had something to do with keeping time or observing the sky. These include the Nidra, the Gossec Circle, Nabda Playa, and finally, around 3000 BCE, give or take 1,000 years, someone finally said, "Hey, are there any good henges around here?" The answer was no, and so with some buddies they built a really good henge, made of stone. Stonehenge. The whole thing is a line towards sunrise on the summer solstice, but they didn't write down detailed instructions, probably because writing had only just been invented, so we don't really know how to henge properly these days. The year is now 2000 BCE, and the Babylonians have noticed that some bright spots on the sky seem to be moving relative to each other, and they've just discovered 5 of the planets. Mercury, Venus, Mars, Jupiter, and Saturn. They don't know what they are yet, but they can watch them and even predict how they move over time. The Mesoamerican long calendar is written down, counting days since a mythological creation day. The authors write down dates that count for thousands of years into the future, stopping in 2012. They're confident that no one would possibly interpret this as a prediction for when the world will end, and they leave the future dates to be calculated by their descendants. In about 750 BCE, Mayan astronomers discover that the moon rises and sets on an 18.5-year cycle. They write down movements of the sun, moon, and planets, largely to use them in astrology, but we won't hold that against them, since back then astrology and astronomy were basically the same thing. Shortly after, in the 6th century BCE, Greek astronomers used this knowledge to predict eclipses. The first recorded prediction of an eclipse was by Thales of Miletus, and records from Greek historians confirm this eclipse over what is now Turkey. Apparently, this helps end a war that's lasted for 15 years, as soldiers lay down their weapons in the sudden darkness. Around the same time, the Greeks also went from believing that the planets were gods to thinking that they are great big balls of rock in the sky. A couple hundred years passed before Chinese astronomer Shi Shen made the first observations of sunspots, presumably using something to protect his eyes, since
the sun is a deadly laser.
He also catalogued the positions of 121 stars in the night sky, something very useful when modern astronomers want to compare our sky to the past. In 387 BCE, Greek astronomer Plato sets up a school that promotes the idea that everything in the universe is moving in harmony, and that the sun, moon, and planets move around the Earth in perfect circles. Just 7 years later, Greek polymath Aristotle described gravity as a downward motion towards the center of the Earth. This was a good decade for Greek scientists. Are you sick of being the center of the universe? Try a new heliocentric idea with the sun at the center, coming to a star near you very soon, said Aristarchus of Samos, but no one listened. Meanwhile, Eratosthenes measures the circumference of the spherical Earth to within 2% of the correct answer. 30 years later or so, and Chinese astronomers make the first definite sighting of Halley's Comet. It's not named after them though, so we'll have to revisit this a few more times before it gets named after a white guy. Is it Ptolemy time? Oh, it's Ptolemy time, said Ptolemy, publishing a catalogue that details 48 constellations, and he also endorses the Earth-centric view of the cosmos, and it's accepted as true for over 1,000 years. In the year 400, in the Hindu book Surya Siddhanta, the length of a year is calculated, giving a number just 1.4 seconds longer than the modern value. In 499, Indian astronomer Aryabhata first explains that planets have elliptical orbits rather than perfectly circular. They spin on axes to give day and night, and they don't emit their own light, but actually reflect sunlight. In 628, gravity is first recognised as an attractive force between bodies. Most other work happening at the moment is to produce higher and higher precision tables of celestial movements, star maps and almanacs, updating older work, and including more and more objects over the next few hundred years. This is done all around the world, including Greek, Indian, Arabic and Persian astronomers, and includes the first observations of Andromeda and the Large Magellanic Cloud dwarf galaxy. The 1000s were a century of two supernovae. In 1006, Egyptian astronomer Ali ibn Ridwan observed probably the brightest supernova ever recorded, at about 16 times brighter than Venus. Not to be outdone, in 1054, Chinese astronomers saw the supernova explosion that left what we now know as the Crab Nebula. It was initially bright enough to be seen in the daytime, but nowadays we need a telescope to see it. Astronomy went a bit quiet during the Middle Ages in terms of big breakthroughs, so let's pick things back up in 1543, with Copernicus publishing his theory that the Earth orbits the Sun. People are finally starting to listen to the heliocentric view, except the Catholic Church. They do not like this idea at all. Luckily, everything we learned before the Dark Ages wasn't completely forgotten, as it was written down in the Baghdad House of Wisdom, and so scholars between the 8th and 13th centuries were able to learn and share lots of what we knew before the world went dark. Then a man called Tycho Brahe, with a mega mustache and half a nose, noticed another brand new, incredibly bright star in 1572. We now call this supernova 1572, and he showed that it was outside the Earth's atmosphere, and that the heavens can change. He was the final major astronomer before the invention of the telescope, and he kept meticulous notes. He was also good friends with Johannes Kepler, who published the 3 laws of planetary motion that are still taught today, and he used Brahe's data to help him plot the orbits he studied. A few years earlier, Italian philosopher Giordano Bruno suggests that other stars could be like the Sun. He is imprisoned and burned alive. Probably unrelated, but be careful out there, fellow starheads. It's finally telescope time in 1608, as Hans Lippershey tried to patent the refracting telescope, and quickly they spread around the world. Alliterative astronomy icon and Bohemian Rhapsody star
Galileo Galilei
built many of these refracting telescopes, but the most important discovery he made was that of 4 moons of Jupiter orbiting Jupiter. This was evidence that not everything was centered on the Earth. The Pope was alarmed and quickly said, you could break a religion with this. Big G also makes observations of star clusters, confirms the Milky Way is made of stars, observes Saturn and Neptune through his telescope, although he didn't realise Neptune is a planet yet, and he sees sunspots changing over time, providing yet more evidence that the heavens are not static like Aristotle had taught. Dutchman Christian Huygens explains the ears of Saturn as thin rings around the planet, and also studies its largest moon Titan. And Giovanni Cassini makes the first confirmed description of a permanent spot on Jupiter. We now know this as the Great Red Spot, a violent storm larger than the entire Earth, that's been raging on the planet for centuries. Some Englishman named Isaac Newton had a busy end to the 1600s. He takes a break from stealing calculus from Leibniz to invent a new type of telescope called a reflecting telescope, explains the splitting of light using a prism, and gifts us the laws of universal gravitation, otherwise known as Newtonian gravity. Comets seen in 76-year intervals from 1456 to 1682 are then shown to be the same comet, and when it reappears as predicted, it's finally named after Edmund Halley, the guy who calculated this. In 1731, John Bevis discovers the now famous Crab Nebula, the remnant of the supernova observed around the world in 1054, while Lacaille discovers the first galaxy beyond the local group, and the first extragalactic deep sky object, the Tarantula Nebula in the Large Magellanic Cloud. Emmanuel can't be stopped as he proposes that the Milky Way is a rotating disk of stars held together by gravity, and he uses the term island universes for other nebulae, which he suggests are outside the Milky Way. Then, in 1764, Charles Messier decides that someone has to make a catalogue of all the things that look like comets but aren't, and that someone should be him. He was only interested in comet hunting, and so he wrote a list of things he knew of that might confuse the hunt, often discovering amazing nebulae and galaxies in the process. Hey, we should use these new telescopes to find some new planets, said William Herschel as he discovered a new planet with a telescope. He tries to name it George to please the King of England, but the rest of the world decides it would be funnier to call it Uranus. As we enter the 1800s, we finally realise that our eyes can't see everything, as Herschel discovers infrared light in 1800, shortly followed by the discovery of ultraviolet light in 1801 by Johann Ritter. breaking light into its component wavelengths with a prism and studying the results. Spectroscopy becomes a method for studying what stars are made of, after it's shown that gaps in the sun's spectrum are linked to the chemical elements in the sun's atmosphere. This is still used to study stars and galaxies to this day. Meanwhile, Giuseppe Piazzi discovers what he thinks is a planet, but eventually we all decide it's too small and come up with a new word for this type of object, an asteroid. In fact, we eventually find loads of them in the same belt around the sun, and we decide to call this belt of asteroids the asteroid belt. This also sets a dangerous precedent of demoting something from planet to not planet, much to the future pain of everyone's favourite dwarf planet. Talking of planets, later this century, people start to notice that Uranus's orbit isn't quite what they expected, and so predict another planet must be out there, pulling on it with gravity. This is immediately confirmed with telescopes, and the discovery of Neptune has officially happened. Friedrich Bessel uses parallax to calculate the distance to another star for the first time, and gets it to within 1 light year of the modern accepted value. Just a year after this, astrophotography is born, with the first ever photos of the moon being taken, paving the way for screensavers everywhere to look pretty. In 1843, an amateur astronomer announced that he's been looking at the sun for 17 years and has observed a regular cycle in sunspot number, giving the first evidence of the goopy internal structure of the sun. During an eclipse, astronomers notice a new bright line in the sun spectrum and guess that it's a new element that they call helium after the Greek word for the sun. And 30 years later, we finally find this element on Earth. The Leviathan of Parsonstown is built in 1845, becoming the first great telescope, with a 6-foot diameter mirror. It's first used to discover the spiral structure of the Whirlpool Galaxy, and remains the largest telescope in the world until 1917. Scotsman James Clerk Maxwell was figuring out the equations to describe electromagnetism, the theory of light, and this allowed him to predict the existence of radio waves, and these were proved to exist 20 years later by Heinrich Hertz. In between this prediction and discovery, dry photographic plates were invented, which are great for photographing the sky, and Jupiter's Great Red Spot becomes an even more prominent feature. Spectroscopy makes another appearance, as William Huggins uses absorption lines to measure the redshift of stars, giving the first indication that they're all moving away from us. Max Planck discovers blackbody radiation, and Wilhelm Röntgen discovers a mysterious type of high-energy light. He calls them X-rays to show how cool they are, and scientists never come up with a better name. He eventually wins the very first Nobel Prize in 1901. Not to be outdone, Paul Villard discovers the even higher energy gamma rays in 1900. And this century is about to go absolutely nuts with probes, spaceflight, and observational discoveries. So strap in. The best catalogue of stars so far is published in 1901, called the Henry Draper Catalogue. And in it, Annie Jump Cannon suggests that we classify stars based on lines in their absorption spectra. This is a pretty good idea, and we still use it today. Some German guy named Albert has some good ideas about speed and light, and then had some more good ideas about gravity a few years later. In between these two papers, Wilhelmina Fleming discovered white dwarf stars, and Hertzsprung-Russell diagrams are eventually concluded to be the best way of showing the evolution of a star. In 1916, another German, this time Karl Schwarzschild, uses Einstein's general theory of relativity to predict the existence of black holes, monstrously dense points of effectively infinite density from which nothing can escape, although their existence won't be demonstrated for quite some time. Henrietta Swan-Leavitt discovers the period luminosity relation for Cepheid variable stars, whose brightness pulses over time. And upon discovering one of these stars in the Andromeda Nebula, Edwin Hubble is finally able to prove that Andromeda is a completely separate galaxy. Arthur Eddington travels to Africa and observes the sun acting as a gravitational lens during a solar eclipse, confirming Einstein's prediction that mass bends space-time. Friedman then derives some equations that demonstrates that the universe is in fact not static like Einstein had suggested. These equations are later independently rederived by Belgian priest Georges Lemaitre, and he suggests that running time backwards in the expanding universe must suggest that the universe started as a single point. This idea becomes known as the Big Bang, a term that may have been originally used to mock the idea by Fred Hoyle, but it's stuck and we like the idea now. Cecilia Payne-Gaposchkin discovers that hydrogen is the most abundant element in the sun's atmosphere, and she becomes the first person to receive a PhD in astronomy. By this point, Hubble had discovered that the universe is expanding in all directions by showing that the more distant a galaxy is, the redder its light is, and the faster it's moving away from us. "It's time for another planet to be discovered," said Clydeswilliam Tombaugh, discovering the planet Pluto. Everyone agreed for a bit, but in 2006 we changed our mind and decided that Pluto wasn't good enough at vacuuming, so it could only be a dwarf planet. Pluto still hasn't completed a single orbit of the sun since it was discovered. Chandrasekhar, Chandrasekhar discovers the maximum limit for the mass of white dwarf stars in 1930. At this mass, the star starts to disintegrate and explodes, and Ballard and Zwicky discover that a neutron star, the densest type of star imaginable, that are made of purely neutrons, can form as a result of these supernovae. The first neutron star is later detected in 1967 by Jocelyn Bell Burnell, who saw pulsing radio light being emitted into space. Zwicky continues to be involved in cosmology, and in 1933 also makes observations of the Coma cluster of galaxies. He notes that they seem to be moving too fast to be explained by normal gravity, and hence he finds the first evidence for dark matter. He even then goes on to suggest that galaxies can act as enormous gravitational lenses, and this is something we observe a lot with modern telescopes. In 1936, Edwin Hubble was busy introducing the names spiral, barred, elliptical, and irregular for different types of galaxy. We now know which of these form early and which form late in the universe, but we named them the opposite way round just for fun. The largest telescope in the world is built with a 200-inch mirror at Palomar Mountain in California, pushing the limits of a single mirror telescope at the time, as larger mirrors tend to bend or break under their own weight. Around 1955, Einstein said, "I will now unify my theory of gravity to also include electromagnetism." But he failed and then died, but not before he wrote some cool stuff on his blackboard. It's time to start going to space! In 1957, Sputnik is the first object to orbit the Earth, and Yuri Gagarin becomes the first person in space just 4 years later. In between those two, NASA is formed in 1958, and it's only 11 years after this that the first human lands on the moon in 1969, having blasted off in what was effectively a modified World War II weapon. In the early 1960s, the first incredibly bright, high redshift objects that become known as quasars, short for quasi-stars, are discovered by Sandage and Matthews. Venera 1 is the first probe sent to another planet, followed closely by NASA's Mariner 2 to the same planet. Now it's 1964, and two men are about to make one of the most important observations in cosmology completely by accident. Penzias, Wilson, and their massive horn have a weird signal that they can't get rid of in their radio telescope. They've accidentally discovered the cosmic microwave background, the afterglow of the Big Bang itself. 60 kilometers away, a group at Princeton University that were planning to actually try and see the CMB for themselves declares, "Boys, we've been scooped." Penzias and Wilson go on to win the 1978 Physics Nobel Prize for their discovery. And over the next few decades, the CMB is observed in a series of more precise missions, culminating in the Planck satellite, showing the temperature fluctuations in incredible detail. Vera Rubin is then on hand to measure the rotation curves of galaxies, and upon seeing stars on the outskirts moving faster than expected, provides more evidence for the existence of dark matter. The first probe lands on Mars in 1976, beginning the age of the machines of the Red Planet, currently the only known planet entirely inhabited by robots. Then Voyager 1 launches in 1977, 16 days after its twin, Voyager 2, and the pair remain active in their missions to study the outer solar system and interstellar space. To this day, Voyager 2 is the only spacecraft to visit either ice giant planet, and it actually passed close to both of them. As if quasars hadn't been perplexing enough already, astronomers observe twin quasars, which are very close in proximity and have identical spectra. It turns out instead that this is the first observed gravitationally lensed object. Saturn's hexagonal storm at its north pole is first observed in 1988, and the Hubble Space Telescope launches in 1990. It immediately needs fixing after all of its first images are blurry. It reached intended quality with the first servicing mission to it in 1993, and the space shuttles delivered astronauts to it 4 times between then and 2009 in order to continually fix and upgrade the telescope. The first exoplanet, a world around another star, was discovered in 1992 around a pulsar, while the first one orbiting a main sequence star was spotted in 1995 and led to a Nobel Prize for its discoverers. 1992 was also the year that the Vatican finally officially declares that the Church is in agreement with Galileo that the Earth is not the center of the universe. In 1995, observations show stars moving rapidly around a very compact object at the center of the Milky Way galaxy, providing the first indirect evidence of a supermassive black hole there. Andrea Ghez becomes the first female astrophysicist to win a Nobel Prize for her part in this work. The colonization of Mars by robots also continues in 1997, with Pathfinder and Sojourner. Reese, Perlmutter, Schmidt and their teams then used supernovae that were brighter than expected to show that the expansion of the universe must be accelerating. "This sounds cool," they said. "Should we trick the US Department of Energy into funding research on this by calling it dark energy?" And they all agreed they definitely should. The first exoplanet is discovered in the habitable zone of its star. Aliens? We all said excitedly into the abyss, and the universe said, not yet. The first fast radio burst is seen in 2001, but we still don't know the causes of these FRBs. That 70s probe, Voyager 1, officially entered interstellar space in 2012, and the Kepler Space Telescope found the first Earth-sized exoplanet in a habitable zone 2 years later. ESA gets the Rosetta spacecraft to orbit a comet and bounce the Philae lander off it in 2014, although it ends up sitting in a shadow and begins a very long hibernation. The past 50 years or so also saw the construction of some groundbreaking telescopes too, including the Keck Observatory, ACT, VLT, the Infrared Telescope Spitzer, the X-ray telescopes XMM Newton and Chandra, Gamma Ray Telescope Swift, and many, many more. 2015 is also the year of gravitational waves, as the first one is seen coming from the merger of 2 black holes. Just 2 years later, the first signal from a binary neutron star merger is seen, and we see the resultant kilonova in regular telescopes too, which is a remarkable multi-messenger observation. It was seen across the electromagnetic spectrum, including with gamma ray telescopes Fermi and Integral, although for this event there were no neutrinos seen that could be attributed to the merger. The Gaia satellite makes a map of the Milky Way containing over 1 billion stars, and the Event Horizon Telescope releases a direct image of the supermassive black hole at the center of the M87 galaxy in 2019. They follow this up 3 years later with an image of the black hole at the center of the Milky Way. One moment of astronomical sadness in 2020 was the collapse of the enormous Arecibo radio telescope, which led the way for 57 years of radio observations. Christmas Day 2021 was the launch of JWST, the next great observatory that's now taking incredible infrared photos of space dust and even crazier space dust. The Perseverance rover lands on Mars to follow on from the huge success of the Curiosity rover. And this one has been buffed to include a copter called Ginny that performs the first ever powered flight of an artificial object on another planet. Thanks to the Kepler and TESS space telescopes, we now know of the existence of well over 5,000 exoplanets, and we expect them to be incredibly abundant around the galaxy and universe. And we also tested the first planetary defense system by crashing the DART spacecraft into an asteroid to show that we can redirect a potentially dangerous impact. Artemis 1 is the first mission as we prepare to send humans back to the moon after 50 years. Tiny cubes could be the future of astronomical probes, and the Euclid Space Telescope is launched with the goal of mapping over 1 billion galaxies. We'll soon see the launch of the Nancy Grace Roman Space Telescope as the next high-profile great observatory, and the openings of the next generation of enormous ground-based telescopes and detectors that will once again revolutionize how we can image the universe. These will include the Giant Magellan Telescope, the European Extremely Large Telescope, the 30-meter telescope, the Square Kilometer Array, Einstein Telescope, Cosmic Explorer, and many more. In the distant future, 1100 years from now, we'll have a new North Star due to the precession of Earth's poles. In 100,000 years or so, the current constellations will be unrecognizable. And over the million years or so that follow, we expect a few moons of Uranus to collide with each other. And in 240 million years, the sun will finally complete an orbit of the galaxy and be back to where it is now. 5 billion years will see the Milky Way and Andromeda galaxies fully merge, and eventually the sun will run out of hydrogen fuel and puff up into a red giant, likely consuming the Earth and Moon. So hopefully any remaining humans have become spacefaring by this point. In 1 trillion years, the 50 or so galaxies in the local group will coalesce into one massive galaxy. From here, more and more stars will start to burn out and extinguish, and the continued expansion of the universe will push all observable objects beyond our horizon, and the night sky will become completely black. Future civilizations will be forced to conclude that the universe consists of nothing but their own planet in a lonely universe. This is the end of astronomy.